Pete Singer, editor of Semiconductor Digest, and I'm here talking to Frank Powell, who's the business development manager for semiconductors at Marposs, and Patrice Belen, who is the product manager for the steel division, STIL, at Marposs. And we're interested to hear a little more about the company and the products and the applications in the semiconductor industry. So maybe, Frank, you could tell us a little bit about the rich history of your company.
Hey, thanks a lot, Pete. The Marposs is a company that's based in Bentivoglio, Italy, which is just north of Bologna. Marposs started in 1952 by a gentleman named Mr. Mario Posati, who developed a product that was revolutionary at the time, an electronic gauge to go inside a grinding machine to control the machine in real time based on stock removal. From that product, Marposs grew for the years in the metal removal business, developing systems not only for grinding machines but for cutting machines, and back in the day transfer machines, which of course are pretty much replaced by milling and CNC machines now. And expanding worldwide, Marposs came to the United States in 1963, and following originally with the OEM machine builders and so on from Europe that transferred here, and grew into a major player in the manufacturing business in the United States, as well as around the world. We're located in all of the primary markets in Europe, Asia, North and South America, with direct offices there. So we're dealing with direct people around the world at the primary facilities. We have a very large presence in China, with a group dedicated to the semiconductor and 3C market there, since that's the center of production for the most part, supporting not only the various machine builders in Asia, but also the end user customers that have the material. Back in 2000, Marposs took on a direction of expanding into new markets through acquisitions. The very first company that Marposs acquired was an American company called Millennium, that at the time produced a machine that was used to align the E-block for the read-write heads for hard drives, and supplied Marposs and Millennium connected with each other by Marposs supplying an optical gauge that verified the alignment that came right after the Millennium machine, and Marposs acquired Millennium. Through the years, Marposs acquired other companies in the various markets and specialized in the various markets. And one of the companies that's very important to the development of Marposs's business in the semiconductor, of course, was STIL. STIL is a company from France. They were the inventors of chromatic confocal technology, sensing technology, and which is a very important product to be used in the building of semiconductor chips as well as the wafers themselves. And so what we're doing now is, of course, we're trying to get a bigger footprint in the production of wafers. Particular, Marposs has about 30 years of experience supplying gauges and systems that go on back grinding and lapping machines, and using not only contact gauging, but interferometric type gauges, where when you're getting these wafers so thin, you need to have non-contact systems. And we have that. With the acquisition of STIL, we're moving more, not only in maintaining our business in the machining side of it, but that STIL gives us a product that can be used in the metrology side of it too. And we're moving more into that, especially in 3C and semiconductors now, with the STIL product as the roots. So that's where we're at today, building on to this market.
Okay, so it's a huge company based in Italy, 3,500 employees. Got your start in the automotive industry and heavy industries, but have recently had a really strong focus on semiconductors, or I guess not so recently, in the last 30 years or so. Oh, and you've got a lot of interesting applications. You'd mentioned a couple. Maybe we could kind of go through those and investigate a little more detail. Ingot slicing, polishing. I don't know where you'd like to start, but I did notice that the ingot sign, you've got a great website, by the way, a lot of good information there.
Thank you.
So, but I was poking around there and I saw that ingot sawing was one interesting application where you can sense if the wire saw has broken or not, and you need to stop the slicing process. So maybe we could start there. Is that you know who are your customers? What are their concerns?
Well, in the case of the ingot slicing, of course, as you mentioned, the process usually use a diamond coated wire and to slice the ingot, and you know you're slicing silicon, diamond slicing silicon. It's two hard metals fighting each other, and what we've found and done with some of the machine builders on this make the machine for this is that we can put first off, it's a continuous wire, so it runs like a chainsaw, for lack of a better definition, for those who know. And there's a lot of pressure, obviously, and running at a high speed trying to cut this. And what can happen is you can have a wire break, and if it's not detected soon enough, that'll cause damage to the ingot and basically scrap an extremely expensive part. So what we've developed is using a acoustic sensor, which Marposs has been doing for many, many years. We can take and place an acoustic sensor next to a bar that runs just above a pulley on the saw, and if the wire breaks, the wire will slap that bar, and we could detect it and shut the machine down immediately. So you don't get any more damage to the machine, you don't destroy the ingot, and you can bring attention to it. Other things we've looked at with it too, that we've been discussing with some of the OEMs on this that make this product, is using a device made by a company that Marposs has called Aerol, which is a laser device that's normally used in wire drawing process to measure the diameter of the wire as it's being drawn, but we can measure the thickness or the diameter, if you will, of the diamond particles on the wire, and we can notify the machine control as they wear, once they get below a certain diameter, that it's time to change the wire. So these are a couple applications when it comes to ingot sawing that we've done.
Okay. So basically, sensors, gauges for various applications, including sawing, obviously, wafer grinding, wafer lapping. What other applications where you're supplying the sensors that are used inside the tool?
Well, now we're from that side. We move into the more of the assembly and the higher side. And what I'll do here is I'll let Patrice explain what we do in the case of the deposition section. So, Patrice, if you could.
Yeah, so still I had developed sensors that can perform measurements under vacuum, 10-6 atmosphere. These kind of sensors are used to align the wafer in the deposition chamber or in some of the etching chambers in order to be sure that the wafer is aligned and that the shape of the wafer is still the one that is expected. So that can help also to control the process. These are the main ideas at this stage. In terms of CMP, Marposs had developed for the wafer lapping and wafer grinding solutions to measure the thickness of the wafer. Could be contact or non-contact. Of course, we manage the environment, so this can be used also to control the CMP process and determine the stopping point. I would say these are the main applications we see in the semicon process, the front end and back end one. Then maybe Frank, we can step to the packaging and 3D packaging.
Sure, sure. But before we do that, I think, Peter, just to understand the root of the steel technology, when I mentioned that they were the company that invented the chromatic confocal, I think a real quick, what Patrice is talking about in these environments is that technology. And the technology is kind of interesting in the fact that we're using, the sensor itself uses a system of initially with white light that is passed through a prism to break it up into the rainbow, all the colors. And all the colors have a known wavelength. So what we do is we send this rainbow down to our target, our sample, our workpiece, whatever it is, and the light reflects back off the surface or off of the various layers within the material, and it comes back to the sensor, and we take and we look at it through a spectrometer, and whatever color is in focus, because we know the wavelength, we know where it's at in space. We know the distance. We know the thickness by taking two colors and combining them and so on. So it's a fascinating process. We're talking nanometer measurements and repeatability using this technology. So that's what allows us to put these things in these environments where you can't touch the part, or it could be hostile. It could be a hostile environment for anything that might try to touch the part, and we can use this technology. We also, because we can take and find these surfaces in space and layers in space, we can also build a picture and get a three-dimensional understanding of the orientation of the piece. So that way, as Patrice indicated, we can check the alignment inside the vacuum chambers, and we can make sure that the piece is in the proper radial orientation as well as is in the perpendicular to the, so it's not in a, what do you want to call it, the pitch, yaw and roll is in the proper orientation for the operations in the vacuum chamber, as well as bringing it into packaging, because now you're taking these chips now are not just single devices. Sometimes you layer chips on top of each other to make a final product. And when you put the two together, the alignment is critical. So you have to make sure that you have a proper two parallel surfaces and aligned surfaces properly before you press them together. This includes things like checking the bumps that are used for the connections, as well as making sure the alignment before the packaging.
So yeah, the bump, for example, we can measure the height of the bump, the isolation layer thickness, the global flatness of the top of the bumps, quite quickly, because compared to some other system available on the market, it's aligned, so there's no acceleration, deceleration between the step and repeats that are used actually. So this is quite fast, and yeah, as Frank said, we can measure the parallelism of the two surfaces when you press the two chips so that you get the bumps soldered together, and that is quite key. And we can also, through some infrared technology, measure the alignment of the patterns to be sure that they match when you want to connect the two chips in 3D packaging.
I know bow and warp and total thickness variation are really critical, but even more critical today when they're stacking these chips on top of one another. So, okay. Now you also offer pressure sensors for 3D components as well?
Yes, we have a division called Artist, which is a machine monitoring system, and one of the things we've been able to apply some of the sensors to is force. It's more of a force sensor, and obviously pressure comes from the force, so we can measure when the proper pressure is put onto anything, because you have to press the two pieces together to form them together. we can, excuse me a second, forgot to silence that. We can measure and control the force and tell the machine when the proper force has been pushed on the part to make to fuse it, and even warn it if it exceeds a level. It comes from this technology is actually comes from our system of monitoring machine tools to detect if there's a crash before it and prevent the crash from being damaging. And we've been able to improve some sensors, some of these force sensors that we use, and produce our own sensors, by the way. But these force sensors, we've raised the technology in those, as well as the software that runs in our controller, to be able to detect very, very, very subtle changes in the force applied.
Okay. And well, what else? What other applications are you involved with in not only the semiconductor industry, but also, you know, optoelectronics, power electronics, MEMS? What the, you know, our viewers are interested in all of those.
Patrice, you want to expand?
Yeah, maybe there's one application that is the micro defect detection with a line camera that we can provide, because it's 100 times the depth of focus of a microscope. So we already have applications on wafer edge inspection, and that is also used in 3D packaging for the wire connection and the wire integrity detection. And because of its large numerical aperture and really large depth of focus. So in one scan, you can get a complete picture quite fast that give you the information to treat and to detect if the wires are cutted or not and well welded or not. That's one first thing. And then we strongly believe that Marposs has a portfolio to help the integrators of equipment in the semiconductor industry, especially for the power supply monitoring management chips, the optoelectronics, and the microelectromechanical system or level chips, where we can measure the pattern dimensions in X, Y, and Z quite accurately compared to the final use needs.
Okay. All right, perfect. Well, what's the best way for people to engage with you? Is it to go to the website, which I mentioned is great, or, you know, give you a call? What's the best way to understand your entire depth of product line and how it fits in with your applications?
Yeah, of course. The best way to contact us is through the website. We have a good sales force and rep force dispersed around the world, but we can't be everywhere and know everybody, especially in this business where there's a lot of confidentiality involved. Contact us through the website, or if you're, you know, or the local Marposs distributor in whatever country you're in. You can directly. Marposs has a very good process of developing an NDA, so confidentiality is an extremely important aspect of our business. I mean, we've been for years and years, we deal with customers in some very competitive markets where confidentiality is the highest, and we wouldn't be in business for 70 years if we shared confidential information. So I know that's a very strong, important thing in this business, and I just want to make sure people understand that that's a very respected condition that we are involved in. So you contact our through our website. We're always in fact, we just got through with Semicon in Taiwan. We'll be at Semicon in San Francisco next July. There's always that way too. So that's the best way to get a hold of us anywhere around the world.
Okay. Well, we'll be there too. So hope to see you then.
Yep.
Sure. All right. Well, thanks, Frank. Thanks, Patrice. And it was great to learn more about Marposs.
Okay. Thank you very much, Peter. I appreciate the time.
Thank you very much, Peter. Me too. I appreciate it. Talk to you.
Okay. Bye-bye.
Bye.
Bye.